Good morning, students. Today we are going to study the fourth experiment, that is colorimetric determination of copper. So colorimetric determination of copper is a spectrophotometric analysis where in this experiment we are using digital photocolorimeter. So when the name itself is mentioned as colorimeter, that means we will be using the colored solutions. So for the determination of copper sulfate solution is having light blue color, but to get a deep blue color we have to add ammonia and prepare a complex solution. So when you add ammonia to copper sulfate, it forms a complex called cuprous ammonium sulfate complex, which is having deep blue color. So by using digital photocolorimeter, we have to estimate the amount of copper present in the given copper sulfate solution. In this experiment, we have to understand 2-3 words. Here we are passing the light radiation. So when the light is passed through a filter of fixing a particular wavelength, then you will get a monochromatic light. Here the wavelength of the radiation what we have to use to measure the absorbance of the solution is 620 nanometers. So that means we have to fix the filter to 620 nanometers. So when the light radiation is passed through the filter, which is fixed to 620 nanometers, then whatever the monochromatic light you will get through the filter will be having 620 nanometers. So when you pass the light radiation through the colored solution, that is the complex solution of cuprous ammonium sulfate, when the light is passed through the color solution, some amount of the light will be absorbed. So now we are using this instrument, the photo digital colorimeter. We are going to measure the amount of light absorbed by the colored solution. So a mathematical expression is there. It works on the principle of Beer-Lambert's law. You will be studying in theory also the derivation of Beer-Lambert's law. Beer-Lambert's law states that absorbance is equal to epsilon Ct. Epsilon is the molar absorptivity constant, C is the concentration of the solution, and T is the path length of the solution. That means when you are passing the light radiation through the solution, it depends on concentration, it depends on path length of the solution. So when you are increasing the concentration, the absorbance increases because A is proportional to C. So the absorbance increases with increase in the concentration of the solution. So please keep in mind that this instrument works on the principle of Beer-Lambert's law, and passing the light radiation having a wavelength of 620 nanometers through the colored solution, and we are measuring the absorbance of the solution. Okay, now coming to the demonstration of this experiment. For doing this experiment, we have to take a series of standard solutions of different capacity. Of this is labeled 50 ml standard flask we have taken and labeled them as blank, 5, 10, 15, 20, 25 and test solution. So we need these standard flasks of 50 ml capacity and labeled as blank, 5, 10, 15, 20, 25 and test solution. Okay, to do the experiment we need 2 burettes. In one burette we have to take copper sulfate solution of 50 ml capacity. In the other burette we have to take 1:1 ammonia solution. Please carefully understand here. We are taking a series of standard flasks and we are taking 2 burettes. In one burette we are taking copper sulfate solution. In the other burette we are taking 1:1 ammonia because we have to form a complex solution of cuprous ammonium sulfate. Okay. If you first we have to prepare the series of standard solutions. For that first we have to take the standard flask labeled as blank. Blank means in this we are not taking any copper sulfate solution. Okay, we are taking only ammonia solution of 5 ml. Okay, so we are taking 5 ml of ammonia into this blank solution. So we are not taking copper sulfate into the blank. Okay, we are keeping it here. Now we are taking the second flask labeled as 5. In this 5 indicates that we have to take 5 ml of copper sulfate into it. So we have to take 5 ml of copper sulfate into the 5 labeled standard flask. Okay, after taking 5 ml of copper sulfate, now we have to add 5 ml of ammonia. See, you are getting color because of the formation of the complex, cuprous ammonium sulfate complex. See, I am repeating. I have taken a 5 labeled standard flask. In this, I am taking 5 ml of copper sulfate, means from 0 to 5 ml of copper sulfate, and to this I am adding 5 ml of ammonia solution and keeping it here. And now I am taking 10 labeled standard flask. In this, I have to take 10 ml of copper sulfate. That means already up to 5 I have added. 10 ml means 5 to 15 ml. So you have to take 10 ml of copper sulfate, and again you have to add 5 ml of ammonia into this, and we have to keep it here. And next we have to take the flask labeled as 15 ml, and this we have to take 15 ml of copper sulfate. That means already it was here 15. So 15 plus 15 becomes 30. So we have to run down the burette up to 30 ml of copper sulfate, and to this again you have to add only 5 ml of ammonia, and we have to keep it here. Now again we have to take the flask labeled as 20, and this 20 ml of copper sulfate we have to take. That means from 30 to 50. You have to run down the burette, so it becomes 20 ml of copper sulfate, and again you have to add 5 ml of ammonia, and we have to keep it here. Now we have to take 25 ml labeled standard flask. Again you have to fill the burette up to 0. Now you take from 0 to 25, so it becomes 25 ml of copper sulfate, and then you are taking 5 ml of ammonia, and you are keeping here. Now you have to take the test solution. The test solution will be given by the examiner. So in this test solution, you should not add any copper sulfate, because copper sulfate is already given by your examiner. So now to this you have to add 5 ml of ammonia. Okay. Now these flasks, I am repeating, blank. We are not taking copper sulfate, taking only 5 ml of ammonia. 5, 10, 15, 20, 25. We are taking according to the numbers corresponding amount of copper sulfate. In all these flasks, we are adding 5 ml of ammonia, including the test solution. Okay. And after adding ammonia, now we have to make up the solution up to the mark with the distilled water. With the distilled water, we have to make up the solution up to the mark, because we are saying that these are the standard solutions. So when I add water, you will get solutions of this type. See the color of the solutions: blank, 5, 10, 15, 20, 25, and test solution. If you see the color intensity increasing from 5 to 10 to 15 to 20 to 25, because we have increased the amount of copper sulfate solution. So with increase in the concentration of copper sulfate, the intensity of the color also increases. So this is the first part of your experiment, that is the preparation of standard solutions of cuprous ammonium sulfate. Okay, this is the first part of your experiment. Stop. Okay, now coming to the second part of the experiment. So we have prepared the series of standard solutions. Now using these standard solutions, we have to note down the absorbance value of the solution. Okay, now we have to fix the filter to 620 nanometers. So here already I have fixed the filter to 620 nanometers. That means I am passing the light radiation, that is called monochromatic light, having a wavelength of 620 nanometers. Okay, now I am taking one small test tube which is called as cuvette. Okay, first we will be taking the blank solution, which we have to shake it well before we are taking. And first we have to rinse this small test tube and take the solution, which is called blank solution, into the small test tube, and take a filter paper and wipe off the small test tube and keep this small test tube in the place which is provided here. Okay, this blank solution is for the calibration of the instrument. So using the blank solution, you have to set the absorbance value to 0.00. By turning this knob, you have to adjust the absorbance value to 0.00 because we are using ammonia in this and water. So to nullify that, we have adjusted the instrument to 0.00 using the set absorbance or OD knob. So once if the instrument is adjusted to 0.00, don't touch any of these knobs. Just you take out the cuvette and throw this blank solution. And now you take the 5 ml standard flask solution, 5 ml standard flask solution, rinse this small test tube and again take the solution into it fully. Take 5 ml solution, and before you are keeping, please remember that you have to wipe off, clean this on all sides and put it in the place and note down the absorbance value. It is showing as 0.11. You have to note down here the absorbance value for blank is 0.00 and for 5 ml we have got 0.11. Okay, now you have to take out the cuvette. I am not touching any of these knobs. Throwing the solution. Now I am taking 10 ml standard flask and taking a small amount of the solution and rinsing this, and again this solution what we have prepared into this, and before again I am cleaning this cuvette with a tissue paper. It should be clean. Then I am keeping it in place, putting the lid. Now I am noted down the absorbance value 0.22. 0.22. Okay. Now again I am taking out this cuvette. Now I am taking 15 ml labeled standard flask. Again rinsing the cuvette and taking the solution into this cuvette. Cleaning on outside. Putting it back here and noting down the absorbance value 0.31. So what I am observing is, with the increase in the concentration of copper sulfate, the absorbance value is increasing. So Beer-Lambert's law states that absorbance is proportional to concentration. Okay. Now I am taking 20 labeled standard flask, rinsing the cuvette, taking the solution into it, cleaning this, putting it back and closing the lid and noting down it is 0.39. Now I am taking the last standard solution, that is 25 ml standard flask solution, rinsing the cuvette again with the solution and taking the solution. No need to wash the cuvette with water because we are increasing the concentration, so it will not affect the readings. So only with the present solution you have to rinse before you are taking that. And noting down the value, it is 0.47. Now we have taken out the readings of all the solutions except the test solution. Okay, before we are taking the test solution, rinse it. We don't know how much amount of copper sulfate was given here. We have to find out. So now you have to rinse this with 2-3 times because we don't know the concentration of this. So better rinse this cuvette 2-3 times and take the test solution into the cuvette and clean this using the filter paper. And keep this here and note down the absorbance value of the test solution. It is 0.29. Okay, 0.29. So I have noted down for all these solutions the absorbance value. So okay, what I have observed when I am noting down the absorbance value, according to B-Lambert's law, when I am increasing the concentration of copper sulfate, the absorbance value also increases, and I have noted down the values in the tabular column, and now using these values we have to find out the amount of copper present in the given copper sulfate solution. After noting down the absorbance values here in the tabular column, we have to do the calculation part for the determination of amount of copper present in the given copper sulfate solution. So we are knowing, we have noted down for blank 0.0, 5 ml of copper sulfate, 10 ml of copper sulfate, 15, 20, 25 and including the test solution. Okay, using these absorbance values, now you have to plot the calibration graph. This is called as calibration graph. To plot this calibration graph, you have to take volume of copper sulfate on x-axis and absorbance values on y-axis. So volume of copper sulfate taken is 5, 10, 15, 20, 25, 30 like that. Each unit you take it as 5 ml. And on the y-axis the absorbance values you take it as 0.5 OD and note down. So for these 5 ml of copper sulfate, blank is anyhow 0.00. So for 5 ml 0.11. So for 5 ml note down the point here. For 10 ml note down the point. For 15 ml absorbance value note down. For 20, 25 ml. After noting down all these points, now you have to draw a straight line passing through the origin, passing through maximum number of points. So using a scale, you have to draw a straight line. It should be a straight line passing through the origin, passing through the maximum number of points. 5, 10, 15, 20, 25 ml. So this is called as calibration graph. Okay, from this calibration graph, for the test solution, you know the absorbance value. So for the test solution, the noted down the absorbance value is 0.29. So correspondingly, for 0.29, you draw a straight line onto the graph and draw one more straight line onto the x-axis. So you are taking the absorbance value on y-axis. From there, drawing a straight line onto the graph, drawing one more straight line onto the x-axis. The point where it touches the corresponding value is your test solution volume. Okay, now you will be knowing what is the amount of copper sulfate given in the test solution from this graph. Okay, now coming to the calculation part, volume of copper sulfate in test solution, you will get it from the graph. Now you have to calculate not copper sulfate, copper. So as per this equation, 249.54 grams of copper sulfate pentahydrate contains 63.54 grams of copper. So whatever from the graph you got it contains how much amount of copper. So copper present in 1000 centimeter cube of stock solution is 1.0185 grams of copper. So copper present in 1 centimeter cube means 1 ml of copper sulfate is 0.0010185 grams of copper sulfate. So now you have to multiply whatever the test solution volume you got you multiply that with 1.0185 milligrams of copper, so that you will get weight of copper in the given test solution you will get in milligrams. So A centimeter cube, A is nothing but your test solution volume multiplied by 1.0185 milligrams. You multiply that and write the result in milligrams. That is the weight of copper present in the given test solution. Okay, now we have to fill this table also. So concentration of copper, from these calculations we have understood it is 1.0185 into volume of the solution. So multiply 1.0185 into 5, write down the value here. Multiply with 10, write down the value. Multiply 1.01 with 15 and write the value. Multiply with 20, write down the value. Multiply with 25 and write down the value. And for the test solution, whatever the value you have calculated here, note down here. So this is the end of the experiment, which is nothing but called estimation of copper colorimetrically using digital photocolorimeter. Thank you.